Greetings once again. Welcome to another edition. In this session, we'll be looking at question number 8, which reads, for part A, sketch and shade the region R in the first quadrant bounded by the lines y is x squared, x is 0, and y is equal to 4. So that is what we need to do first. So let's quickly sketch this area or this region before we can even worry about doing some integration. So we'll have the y-axis and the x-axis. So if you look carefully, they say that we are bounded by x is 0. So we know the x is 0 line is that. So I'll have x is 0. And we are bounded by y is 4. So I'm just going to draw a line for y is 4. That will be the line for y is 4. And then we have a curve which is x squared. So the curve will just be something like this. And obviously, where the curve intersects with the 4, the corresponding x value would be a 2 there. So if you look at how this is, it means the region which we are interested in, or our region of integration, it would simply be what is inside here. That is our region R of integration. So let's quickly go now to B, now that we have R, and figure out how we can integrate that. So for B, we need to integrate x multiplied by e to the y squared dA. And this is in our region R. So we have two options really. So let's explore them. So option 1, what we want to do, or what you can do, you can integrate in this particular order, y squared. So option 1, you can do dy dx, and option number 2, when doing your integration, you can, put in our region, you can choose to do dx dy. So x e y squared dx dy. So let's look at these carefully, both of them. So if we start by integrating with respect to y first, it means that you need to be able to integrate e to the power of y squared. And as it stands, with your course, you are not equipped to do that. So you are not equipped to be able to deal with integrals like e to the x squared, as an example, dx. This here is not easy. You are not used to dealing with this. So you would rather try to run away from starting with that. And if you look at option 2, for option 2, we are going to start by integrating with respect to x. So when you just integrate x, that looks doable. So what we are going to do is we are going to start by integrating with respect to x, because it is what we can do. So if we start by integrating with respect to x, this means that I need to go to our region and make a horizontal cut, and then start finding our limits of integration. So let's go ahead, because we want to integrate with respect to x. I'll just make a horizontal cut like this. And if you look carefully, the x here should be 0. And the x there should just be square root of y. That is what we have. Then when we think of the y, if you think of the minimum y value, it will be 0. And if you think of the maximum y value, it will be 4. Okay, so we are ready now to set up our integral and start doing the actual integration next on the next page. So if you look carefully, this means that I'll have my double integration. The y will be outside, 0 to 4. And for the x, I will have 0 to square root of y, and then I will have xe to the power of y squared, I'm going to have dx dy. Now let's go to the next page and compute this integral and see if our life has been made easy in a way or another. So let's do our integration here. So we have 0 to 4. We are integrating with respect to x. So we'll end up having half of x squared, ey squared, and then plus some constant, call it c. And this is going to be evaluated between 0 and square root of y dx. So wherever I see the x here, I'm going to replace it with the square root of y. So we're going to have 0, 4. And if you look carefully, we just have half of square root of, the dx or the dy comes afterwards. Square root of x all squared e to the y squared. And when we substitute 0, obviously everything will be 0. So I'll leave this as dy. So if you look carefully, we are putting square root of y. My mistake there. So we're putting square root of y like that. So if you look carefully, our integral will end up being 0 to 4. Then we'll just have half of y, then e to the power of y squared dy. So I can just pull out the half. Then what I have is just y, e to the y squared dy, 0 to 4. Then this is where now my techniques of integration, they come in to make my life to be easy, because I can choose to do your substitution here, but I can choose not to even. So if I'm deriving, as an example, with respect to x, I'm deriving e to the power of g of x. All what this will be, it will be e to the power of g of x multiplied by the derivative of g of x, like this. So what I'm able to see is that I can have a half, pull out a half, then have the integral here. Then I'll need to introduce a 2 inside because I pulled out a half. Then I'll have e to the y squared dy. So what am I seeing? I'm seeing that that derivative will give us that. The same way, the derivative of that, if it gives you what is there, you can just revert back and equate your answer to that. So if you look carefully, I'll have 1 over 4. Then when we do our integration, it will be e to the y squared, then plus some constant evaluated between 0 and 4. So if you think carefully, so if we substitute there, you'll see that we'll have 1 over 4 e to the 4 squared and then minus e to the 0. And this just becomes 1 over 4 into e to the 16 minus 1. So this becomes our final answer, which is the integral of what we were looking for originally. So that is how we are supposed to deal with this problem here. So let me make some space. There you go. So that is our solution for that question. I hope this makes sense and it clears and helps your understanding of switching off variables, well, not variables, but switching off the integration limits, and how you make a decision on which one to go for and which one not to go for. Okay, cheers.